Wormholes are one of the most fascinating deep space phenomena. Scientists have long theorized and investigated wormholes, but they have only recently discovered the first wormhole. Scientists had recently discovered the first wormhole, but there is something more to it, and astronomers are so excited about it. And how does it affect us personally? We will explain everything in this video. We are protected from things that would surely kill us because of the unique properties of the Earth. But once you leave the planet, everything changes, and the further into space you travel, the worse things appear. A wormhole is one of these things. A wormhole is both interesting and terrifying, as you will discover. Due to scientists' unceasing curiosity, they have learned a lot about wormholes and even built one. But what precisely is a wormhole? For understanding the wormholes, you must first give a thought upon its natural meaning. A wormhole is a tunnel-like hole made by a worm into fruits or trees. In the similar manner, a wormhole with context of physics is a tunnel between two locations of space-time. In the Nolan movie Interstellar, it was explained like this. Imagine space-time to be 2D surface. Draw a line on it. The two extremes are located at a large separation. Now, what wormholes essentially do is fold the surface so that endpoints meet, and now shortcut is directly through the 2 points. That's a wormhole. Let us ask a simple question. What is gravity? Before Einstein, we strictly followed Newtonian maths, meaning those 3 laws. However, as per Einstein, everything is with respect to space-time fabric. I disturb the space-time fabric, and so does Earth, which is why we both fall into each other's wells, thereby causing attraction. It was only in this maths that existence of these shortcut tunnels was proved, not found in universe till date. Also, size of wormholes may not be large enough. Now, there's another theory stating that virtual particles cannot be stable for too long. This may mean that wormholes may form and then disappear, making space-time travel more difficult. In short, wormholes are just the theoretical tunnels between two locations of space-time fabric. Space-time, meaning two ends can be in two different spaces or two different times, or both. To make it more simple, let's take help from Einstein. Einstein's general relativity equations have a solution called a wormhole, which creates a tunnel between two distant places in space or time. In this case, the tunnel's length is shorter than the distance between those 2 points, which means you can refer to wormholes as a shortcut between 2 points. Even though they have been depicted in numerous science fiction movies, wormholes have remained hypothetical for a long time. However, with the recent discovery, that is no longer the case. You may have heard of wormholes referred to as Einstein-Rosen bridges. That is due to the fact that the brilliant scientist Albert Einstein and Nathan Rosen in 1935 found the most straightforward wormhole solution. The pair began by calculating the mathematical formula for a black hole. A black hole is another scary phenomenon. A black hole is a region of space-time where gravity is so strong that nothing, not a single particle, or even electromagnetic radiation such as light can escape from it. A sufficiently compact mass can deform space-time to form a black hole. According to the laws of physics, they discovered that they could extend the solution to include white holes, which are the polar opposite of black holes, in that they behave in the opposite way from black holes, in that they don't allow anything to enter their event horizon, and any material inside of one is immediately spat out. This is where the wormhole comes in. Einstein and Rosen discovered that there is a white hole for every black hole in space. Since the two holes would be located at different locations in space, a wormhole would connect the two ends. Despite the fact that wormholes are possible, stability was a problem, since a single photon or light particle going through the wormhole tunnel would add so much energy to the system that the tunnel would shatter, eradicating the wormhole. Additionally, you might be mistaken if you thought of a wormhole as a cozy, secret route you could use to travel from one part of the universe to another. Since you can only enter from the dark hole side, doing so would require you to cross the event horizon, which is something you will never be able to do. If you were to leave, you would be stuck in the associated wormhole forever. But finally, scientists discovered a technique to create a stable wormhole and even make it traversable. such that solving a few mathematical puzzles will free you from your wormhole's perpetual prison. Stabilizing a wormhole involves stabilizing the tunnel itself and relocating the wormhole tunnel's entrance outside the black hole's event horizon so that matter flowing through doesn't immediately and catastrophically collapse. Now, scientists believe instead of traveling for many millions of years from one galaxy to another, under the right conditions, one could theoretically use a wormhole to cut the travel time down to hours or even minutes. Because wormholes represent shortcuts through space-time, they could even act like time machines. Researchers found that negative mass matter, often known as exotic matter, is necessary for these conditions. Negative mass is an intriguing concept, and recent study indicated that wormholes containing unusual matter could remain open and unchanging for longer periods of time. Exotic matter is distinct from dark matter or antimatter. There is also the issue of size, as in the example where an object with a negative mass is placed next to one with a positive mass. The object will begin to accelerate even in the absence of any source of energy. However, as the universe expands, it is possible that some may have been stretched to larger sizes. If you were to enter a primordial wormhole, what would you see? Scientists discovered that it would be strange. The entrance would be a sphere, similar to what you would see if you were looking at the surface of a planet. If you peered into the wormhole, you would see light coming in. The wormhole tunnel might be any length from the other side as you traveled through it. And as you traveled through it, you saw distorted views of the area, the cosmos, and the destination. Wormholes can also turn the popular idea of time machines from movies into a reality. How does this function? Starting with special relativity, which states that moving clocks tick slowly. If you were to build a wormhole, the two ends would initially be synchronized in time. However, if you accelerated one end to almost the speed of light, that end would start to lag behind the other end, and the two entrances could then be brought together. However, one of the entrances would be in the past of the other. While this may seem like a lot to process, it is only necessary to walk through one end of the wormhole to travel back in time. By the time you emerge, you will be rejoicing in your own past, allowing you to literally relive some moments of your life. In the meantime, despite all of our research into wormholes, we have yet to see one in space. However, a team of scientists decided to make their own wormhole in a laboratory. If you are concerned about the potential consequences of this work, don't be. They have done their jobs perfectly. These Spanish researchers from the Autonomous University of Barcelona have created a spherical device that can transmit a magnetic field from one location in space to another. Alan Greenleaf, a professor of mathematics at the University of Rochester in New York, developed a theoretical model of an electromagnetic wormhole that could transmit electromagnetic waves through an intangible tunnel between 2 points in space. However, Greenleaf's theory was never tested for a number of reasons, but the Spanish team was able to use magnetic metamaterials and metasurfaces to create an electromagnetic wormhole, and for good news, the required materials already exists, making it simpler to obtain, as one of the researchers, Geordie Prackham, claimed they discovered after conducting thorough investigations that the Greenleaf's concept may work. After the team completed the design, it took 4 months to build the wormhole. The overall result is that a magnetic field appears to go from one point to another through a dimension that is outside of the typical 3 dimensions. The wormhole in this experiment is a sphere with 2 inner layers composed of superconducting material and a ferromagnetic sheet folded into a cylinder that traverses the sphere from one end to the other. The sphere is designed to be magnetically undetectable and invisible in magnetic fields. The architecture of space is altered by the magnetic wormhole, making it similar to gravitational ones in that it appears as though the inner region has been magnetically wiped. These scientists had previously created a magnetic fiber that was capable of moving magnetic fields from one end to the other. The wormhole they have now, however, is a fully 3-dimensional gadget that is undetected by any magnetic field. It's noteworthy that there is a practical use of what the Spanish team of scientists has produced. This fiber was, however, magnetically detectable. In the medical field, magnetic fields are frequently used. For example, the technology can make patients more comfortable during MRI scans by allowing them to be farther away from the detectors. It can also assist in obtaining several MRI images of the body at once. While scientists continue to investigate wormholes, the question remains as to how they can establish their existence. They may be at the heart of some very brilliant galaxies, according to Russian researchers, who also recommend specific studies to detect them. This is based on calculations of what would occur if two matter, one coming out of the wormhole and the other falling in, collided. The collision would produce a stunning display of gamma rays, which we may try to witness with telescopes. Scientists previously believed that a wormhole and a black hole couldn't be distinguished from one another, but this radiation can help recognizing the wormhole. Let's hope they make more fascinating discoveries about wormholes, and we'll keep you posted to them. That pretty much wraps this video up, guys. Thanks for watching. Let us know of your opinions in the comments section below. Remember, be sure to subscribe to this channel with bell notification if you enjoy watching our content. We upload some pretty awesome stuff here, which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.